Okay, this is our third video on the introduction to sequences. In this one we're going to talk about recursive definitions. You can see the page number and objectives here. So a recursive definition is different than explicit definition, and this is something that you need to be comfortable with. In fact, you need to be comfortable with both explicit and recursive definitions. The explicit definition is designed to enable you to find any term of a sequence quickly using a formula. So the explicit is a rule that uses a formula. That's what we saw in the previous video. Now that's different than the recursive. What the recursive does is it uses a pattern to move from term to term. Okay, so when you think back to your previous math classes and working with sequences, more likely than not, you probably remember using a recursive rule instead of an explicit rule. So let's do an example of a relatively quick one. Let's go back to our set of even numbers. The sequence of even numbers looked like this. So in a previous class, you might have done something like describe a rule that tells you how to move from one term to the next. So in this case, how would I move from 2 to 4? Using the same rule, move from 4 to 6, and then using the same rule, move from 6 to 8. Well, I think the way that I would do it is that I would add 2. 2 plus 2 equals 4. 4 plus 2 equals 6. 6 plus 2 equals 8. So I think my rule here, or my pattern, maybe is the better word to use, the pattern is add 2. That's my pattern. This is the basis to recursive definitions. So a recursive definition is different than explicit because the explicit gives you a formula that lets you find any term you want. But in the recursive definition, you're using a pattern to find one term based on knowing the previous term. In other words, to know what this term right here was, I had to first know what the term in front of it was, so then I could add 2. And then to know what the term in front of it was, I had to first know what the term in front of that was so that I could add 2. And so on and so forth. So this is based on knowing a pattern, but it also requires us to know certain terms. All right, now let's look at how I would write a recursive formula or a recursive definition. Okay, it requires me to do 2 pieces of information. So the first piece of information that I have to know is a term. And then the second piece of information that I have to know is the pattern of how you move from one term to the next. If I know those 2 things, then I can find any term I want. It might take a little work to find terms much farther down the list, but I can find any one I want. So it does take both of those things. And so what we do first of all is we make it look kind of like a piecewise function. We say to find the nth term of a sequence, use these 2 rules. So that's the way I would write this so far. Now let's actually think of a sequence. So I'm going to say that in sequence A, the way I find the nth term is like this. If n is equal to 1, then the nth term is 3. Now what does that mean right there? That's the information that's telling me about a term. It's telling me that the first term is equal to 3. So this part of my recursive definition tells me what the first term is. Specifically, the first term is 3. Now the second part needs to tell me a pattern. In other words, how do I find the next term? Well, let's say that our pattern, our rule, is that we're going to add 4 every time. That's our rule. So somewhere in my next part down here, there's going to have to be a plus 4. What is it I'm going to add 4 to? Well, it's going to be, I'm going to add 4 to the term in front of the term that I want to know. So how do I show that with a rule? Well, this is the way that mathematicians have developed. They say in sequence A, if you want to know term number k, then use the term that comes before it. So if k, think of your favorite number, let's call that k. How do you find the number that comes before it? Well, if my favorite number is 5, the number before it is 4. If my favorite number is 12, the number before it is 11. How I find the number in front of my favorite number is I just subtract 1. So the way we write this is a with a subscript of k minus 1. And so this is the way that we write a recursive formula. Again, it has 2 parts. It has something that tells me a term, usually the first term, and it has something that tells me a rule. Add 4 to the term that comes in front of the term you want. So let's write out what the first 5 terms are for this sequence. So according to our rule here, the first term is 3. Now, the way I find the next term, according to this part of my rule, is I add 4 to the term that comes in front of it. So think about this. Right now I'm trying to find term number 2. So if this k right here was instead a 2, then this k over here would also be a 2, and that would tell me to take term number 1, because 2 minus 1 equals 1. Term number 1 and add 4 to it. So here's term number 1. If I add 4, I get 7. Now, how will I find the next term? Well, the next term is the third term. So now I'm trying to find out term number 3. So now k right there turns into a 3, which makes this k turn into a 3. So now this says 3 minus 1 is 2. It's telling me use term number 2 and add 4. So term number 2 was equal to 7. If I add 4 to 7, I get 11. And then we just keep going this way. To use my rule again, I'm going to take 11 and add 4. That gives me 15. To use my rule again, I'll take 15 and add 4. That gives me 19. And I'll keep going like this for as long as I want. ... Okay, so this is the idea of how to use a recursive formula. Let's do one more real quick. Let's say that for the nth term of a particular sequence, if you're trying to find the first term, you should use the number 5. And if you're trying to find the kth term, then you should do 2 times the term in front of k. Pause the video now and see if you can find the first 5 terms. First 5 terms. Pause the video now and see if you can find those. All right, hopefully you found those terms. If not, let's talk through this real quick. So if I want the first term, according to my rule, the first term is equal to 5. Now if I want the second term, according to my rule, I'm going to multiply the previous term by 2. So there's my previous term times 2, I get 10. Now for the third term, I keep following this rule. So now I take my previous term and I multiply it by 2, so I get 20. Then I take this and I multiply it by 2, so I get 40. Then I take the previous term and multiply by 2, so I get 80. And those would be my first 5 terms. All right, so now to finish the video, what I'd like you to do is come up with a recursive formula on your own. So I'm going to give you some numbers in a sequence, and I want you to try and build the recursive formula. So here are some numbers. 3, 2, I'm sorry, not 2, negative 2, negative 2. 3, negative 2, negative 7, negative 12, negative 17, ... Okay, so here are some numbers in a sequence. I would like you to come up with an explicit formula. If you'd like to pause the video and try it on your own, feel free to do that now. If you want to follow along with me, here we go. We know that the rule for finding the nth term is going to have 2 parts. And so that's where I begin, is trying to find the 2 parts. The first part is relatively easy. I just need to know what the first term is, and I can see in this case the first term is 3. But now I need a rule for how to move from one term to the next. So that's going to give me a formula for how to find term number k based on knowing k minus 1, the term in front of it. So let's think about, how do I go from 3 to negative 2, and then a same rule to go from negative 2 to negative 7? Well, maybe you recognize that from negative 2 to negative 7, I've subtract 5. And to go from negative 7 to negative 12, I've also subtract 5. Is it true that if I go from positive 3 to negative 2, have I subtract 5? Oh, yes, I have. So we seem to have found the rule. The rule is to take the previous term and subtract 5, and that's all they've done here over and over again, is subtract 5. So it looks like my explicit formula should say, take the previous term and subtract 5. So this is my recursive formula. And that would be my answer to a question that asked me to find the recursive formula for this particular sequence. Don't forget that you do have 4 problems in your textbook tonight for homework. They are found beginning on page 807, problems 9, 45, 63, and 79. When you come into class tomorrow, we'll review the material in these videos, as well as those 4 problems, and then start looking at some more sophisticated examples.